This is day 21 of Advent of Code 2023, and this challenge is called Step Counter. You manage to catch the airship right as it's dropping someone else off on their all-expenses-paid trip to Desert Island. It even helpfully drops you off near the gardener and his massive farm. You got the sand flowing again. Great work. Now we just need to wait until we have enough sand to filter the water for Snow Island, and we'll have snow again in no time. While you wait, one of the elves that works with the gardener heard how good you are at solving problems and would like your help. He needs to get his steps in for the day, and so he'd like to know which garden plots he can reach with exactly his remaining 64 steps. It gives you an up-to-date map, the puzzle input, on a starting position, S, garden plots, dot, and rocks hash, for example. So the elf starts at the starting point S, which is right there, which also counts as a garden plot. Then he can take one step north, south, east, or west, but only onto tiles that are garden plots. This would allow him to reach any of the tiles marked O. So he can go north and then west. Then he takes a second step. Since at this point he could be at either tile marked, his second step would allow him to reach any of the garden plots that is one step north, south, west, or any of those. So he could come back down to his starting position there, or go like that. Then after 2 steps, he could be at any of the tiles marked O above, including the starting position. Either same thing again, so that's the starting position. So for this one, it's like up, down, up, while this one is up, up, right. Okay, and he'll continue like this until his steps for the day have been exhausted. After a total of 6 steps, he could reach any of the garden plots marked O. So in this example, if the elf's goal was to get exactly 6 more steps today, he could use them to reach any of 16 garden plots. However, the elf actually needs to get 64 steps a day, and the map he's handed you is much larger than the example map. So starting from the garden plot marked S on your map, how many garden plots could he reach with exactly 64 steps? Okay, so part 1 sounds relatively easy. So let's do this. We'll create the grid, go part 1, let's do starting equals, actually we want to do for row in grid in enumerate grid, then cell for CI cell in enumerate row. Actually no, we don't need to do that. If S in row starting equals RI row dot index of S. Can't actually remember the proper syntax for that. Print starting. Oh, okay, firstly need to change that. Index 5. Okay, cool. So we've got the starting position, and for in range, we'll start off with 16 so we can do the test one, and we will do current positions equals starting. So we'll have a set of the locations, because there is a possibility where it's like, let's say this one, both of these could go back to the starting one, but you would only count that as one, so we'll do it as a set, so we just add on to that. So for in range 16, okay, we should also get coordinate stuff, so like north, south, east, west. If we can, we'll just use this one, and we'll do directions equals up, down, left, right, and we can do so we can do current positions equals for pos in current positions, then for dir in directions, if grid, actually looking at this, we should also do grid starting 0, starting 1 equals dot, so then it doesn't mess anything up. So for this, if grid pos 0 plus dir 0, and then pos 1 plus dir 1 equals dot, we then do pos plus dir, print current positions, exit. String does not support item assignment. What is that, 21? Wait, what? String does not support item assignment. What is it on about? Print this. Okay, what does starting have? Oh, okay. I forgot to dot split this. Empty separator, yeah, that's the point. Print grid. Or do I need to do this? Can't I just split on an empty string like that? I swear I've already done that before. No? Okay, well I guess we'll do this then. C4 C in. There we go. And we have, okay, that's not what I was wanting. I guess we'll have to do it like this. 0 plus 0, then 1, 1. So it's now 4, 5. So it'd be 4, 5 and 5, 4. Okay, that looks like it's working. So now with that, let's print length Oh, actually, return length of current positions. Wait, it wasn't after 16, it was after 6, wasn't it? After 6 turns do that. So range 6. And a return 16, awesome. So 64 steps, and we'll grab part 1, or the input. That is a large grid. So we'll now chuck that into here and run it. 3, 6, 8, 7. Cool. And now that is part 1 done, so let's go on to part 2. Elf seems confused by your answer until he realizes his mistake. He was reading from a list of his favorite numbers that are both perfect squares and perfect cubes, not his step counter. The actual number of steps he needs to get today is exactly that number. He also points out that the garden plots and rocks are set up so that the map repeats infinitely in every direction. So if you were to look one additional map width or map height from the edge of the example map above, you would find it keeps repeating. Okay, this is just a tiny 3 map by 3 map slice of the inexplicably infinite farm layout. Garden plots and rocks repeat as far as you can see. The elf still starts on the one middle tile marked S, though every other repeat S is replaced with a normal garden plot dot. So the numbers for reachable garden plots in this infinite version, that's what those numbers would be. So however, the step count the elf needs is much larger. Starting from the garden plot S on an infinite map, how many garden plots could the elf reach in that many steps? Okay, interesting. So we'll change it back to this. Let's copy this to here for now. So let's just grab that number and we'll do target equals this. So do the same thing here. So 26 million. We might be able to iterate over that. Just thought I'd take a look at the input. Something interesting. It looks like a diamond. It's a diamond and then it would repeat. So if you were to put one to the right, one above, one here, it would all match up. But it doesn't seem like it matches the middle one. Like you can say 2, 2, 1 right there. There's no 2, 2, 1 here. Interesting, but I don't know if that can be used in any way. Something to think about to make this quicker. So it's every time you move, say go here. So you move from here, you go to here, and then you would be able to go back to here. So you could kind of expand on it. So instead of doing like 1, 2, 3, 4, you could go 1, 3, 5. Just do every second one. You could like, would that work? I think you could like remove every like odd row like this. Actually maybe not. Because if you had like every odd one removed, you could just do a direct line, and you'll be doing half the amount of steps. But maybe that's not correct because obviously you've got stuff like this blocking, which is needed. Or maybe you keep like that and just do like 2 up, like starting here. You could check like here, 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 like go around you. Okay, that is an idea. So check around to see which ones you can move to, but then you would also have to check if these are there. Because if say because let's say this hash is here, you wouldn't be able to go either of these positions. Or if hash is here, you can't go like here, 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 or here. Are there any dots in here where they're like fully enclosed? Right here, okay. So that is a dot which can never be reached. So you can't just do like a blanket dot search over every dot, because there are some that you just cannot reach at all. Okay, so I guess first thing we can do, reachable pos. This will equal starting. So we then need to figure out which positions can actually be reached. So we'll do, can probably just do this, and then do C cell if cell equals dot, and we'll do, what do we want to do? So it'll be a similar thing to this. Actually, out of curiosity, this map, how large is it? So it goes up to 131. Are we in the middle? So one that's like 65. Okay, we are dead center in the middle, 66 there. So that means there's 65 above us. Okay, I've got a good idea for this. So reachable pos. Okay, yep, got it. Or an idea. So basically this, but we run it 65 times, and we change it to reachable pos. So basically, after 65 iterations of this, we would have made it to every single edge that can be basically gone to. Actually, let's just print reachable pos just to look at that. Line 33. Did I mess that up again? where it is not associated with a value. Oh, okay, so we need to actually change this. Let's do that. Because we've already overridden that value. Current positions, that'll be reachable positions now. Actually, the part 2, let's do 3, 7, 7, 8. So this is 132 by 132. How large is that? Okay, 17,000. So because it's going back and forth, basically just divide this by 2. Does that look like an accurate number? I think that'll be fine. Makes sense. Actually, should this be 65? Or should that be the length of this? Length of grid? What does that do now? Right, I can actually go outside. It's gonna look so ugly, but we're gonna be... and this greater than 0, greater equal to 0, and this less than length of grid. And then we're gonna be doing the exact same thing again. 1, 1, 1, 1. Does that fix that? Nope. Because this condition should be at the very end. So do that. 7, 4, 2, 3. That doesn't sound right. Okay, maybe we should keep that as it was. So running 65 times. Okay, this is odd reachable. Okay, maybe what we do... Actually, maybe we do what we had before. Length of grid. We'll do size equals length of grid, because I'm going to be reusing this number a bit. So size, and we'll do modulus if it goes over, I guess, because that could work. Do chord equals this, so we don't have to keep typing that out. Oh wait, that doesn't work. Never mind. So we'll now, wherever it's used, we will do modulus size. So if we run, let's print, this should be all reachable, length, all reachable, so 40. Okay, so we've got that number. If we do a +1, I think it would say the exact same. Yeah, so we've now got every single possible location they can move on to, I think. I'm just going to kind of change the number and see if that worked. Okay, so if we do a -1, it should go less, I think. Yes, okay, so we've got every possible reachable location with that. Okay, good. So we've got odd reachable, and we do want to, as I was saying before, doing like the jumps to like that. So what do we want to do for this? We want to basically calculate all of these on top of each other. Okay, yep, that makes sense. So like up, down, that'll be 0, 0, so that's 2 steps. Up, up, that'll be -2, down, down, 2. And then also these. Okay, so 2 steps equals, it'll be a set for dirt and directions. This will be dirt 0 plus dirt 0, dirt 1 plus dirt 1. So now let's print 2 steps to make sure that does as we expect. That's not right. Oh, okay. Then for dirt 2 in directions, need to be doing dirt 2. There we go. So we've got all possible directions that can go in 2 steps. Okay, so is there anything special about this number? So it's that many steps going outwards. Let's get a calculator out. Well, the number ends in 65, so maybe that's a giveaway. 2650135 divided by 65? Maybe not. 2650135 mod 65? 20? Actually, I don't know. That doesn't do anything. What about 2650135 divided by 130? Wait, is that 130 or 132? Divided by 131? 2650135 mod 131? Okay. I'm not sure if that actually helps. Actually, something I just realized as well with this. We need... well, we should probably get even as well. Even reachable. And this will be 64. So we've got the odd and then the even. So all reachable minus... Let's do odd reachable minus even reachable. Just to verify this works. I've got the minus. I thought that would have given a 0. Length, and then length. Did I mess something up there? Let me just record this quickly. So we've got that number. What's 33778 plus 3687? 7465. That's close to that. So can we figure out the total size of it? So total size. This will be target So total size, we've got the main size of it, or we've got the target of it, which is not small steps, and it'll be going in both directions. So it'll be going target amount this way, target amount that way, so target times 2. Let's print total size. Total size. So that's the amount of cells, but because we've already got a grid, should probably record the grid is more important than the actual size. So divided by size, maybe? Okay, well that gives a fractional number plus 1. Okay, that looks more like it. So, so 404,000 total grids that I can move. We'll do slash slash so it removes the decimal point from there. So if now I've got a total size or total grids. Okay, so what do we do with these numbers now? Still need to figure out like the actual movement of it. So we've got all reachable, we've got odd reachable, we've got even reachable. We have the 2 steps for more quickly going through it. Is that needed? Man, to be honest, I'm not sure how to do this part. Like, I know whatever I'm gonna do is gonna be wrong. These challenges are starting to get a bit too complicated for me. Like, just maths and stuff that I don't know. Okay, yeah, I'm gonna look up a solution because I'm not sure how to progress any further. Okay, so I've found someone else's solution, and I was on the right track, but yeah, looking at it, I was like, I don't even know what's going on. So firstly, don't need the 2 steps because apparently you can figure this out without actually calculating all that stuff. And so from here onwards, we do all odd reachable. So apparently, I thought this would have been everything else needed, but apparently not. So we then do for x in range size, then for y in range not x modulus 2, so every odd number, but because it's a grid, it's 0, 1, which would then be the even in the grid. So not x2 size, then increment by 2. So doing that, oh no, this is odd. Right, okay, yep, no, that's correct. We start at position 65, so it's all the even numbers which are actually even. So, and reachable. And then apparently same thing for the equal sign. Oh, I forgot to also do this. So this would be x, y. No, that should be y, x. Wait, am I getting this mixed up? Oh, sorry, all reachable. Okay, let's just change that even. And this one is just x. Let's print all even to see what, the print length of that, to see what that is. 7490. Okay, how does this all even from even reachable? Oh, okay, we'll change this. We'll add the print back in. So even reachable, all even reachable. So that changed it all. And I forgot to do length. Okay, those look the same. Well, I'm not actually sure what that is. Okay, well, I mean, it's doing something that I don't understand. That's why I'm not doing this myself and following on someone else's solution. So next thing to do is outer odd equals all odd reachable minus odd reachable. Okay, so what does that do? Oops, accidentally put 2. Okay, so what is... So we have this one, and then we've got outer. I'm not actually sure what's going on, but we will try carry on anyway. So now it would be outer even, so all even, and then even. So if now I've got those 2 numbers. So something that I noticed that they're doing is they're doing complex. Oh, complex for theirs. I have no idea what complex is, but if they're doing it, I should probably do it. Then they've also got all this different as well. So we'll put that in here, just so it's separate. And then this is negative 1j, 1, negative 1, 1j. I got no idea what that is doing. What? Okay, so they're using real and imaginary numbers, which I don't understand. Then we're gonna have to change a bunch of stuff here. Okay, well they also got their own way of doing the grid, so I'm gonna also change that. Doing for y in, this will be one line in enumerate, then xc in enumerate, then there, Then they're doing complex. Why? YXC? What? Oh, their grid is a dictionary. Okay, we'll do it exactly how they've done it. So put this into their grid equals this. Like that. I got no clue what's going on anymore. Print grid. What? Okay. I got no idea what's happening with that, but sure. So we now need to go back to here and change all of these. So this would now be, I think, pos plus dir equals that, and then just pos plus dir for everything else. Okay, let's see if that is correct for this. Let's run that. Okay, I think this would need to be complex like this. So I got pos and all reach. Oh, that might have been an issue with the numbering before, but you've also got something for finding opens equals k for kv in grid dot items if v equals dot. So instead of doing this, they're doing if this in here instead of doing that. So let's see if that will now work for us. Why isn't this working? Oh, it's because of here. What would it be? Starting equals complex starting 0 starting 1? What does it mean? What? Okay, well I guess I gotta change this as well. We're gonna do this equals s because we've actually reread it. Will that work now? Oh, they've got a comma here. Now we've apparently got an infinite loop somewhere. It's in here. Okay, maybe I should print size. Okay, well we're changing it so length. We're going to do f dot read dot split lines. Now that should work. Proper size note. Built in. Oh, not enough values to unpack. What? Oh, it's because I did that. Okay, we're changing this. Lines equal this, and then we're going to go through it twice. So back out to here. Length of lines for line in lines. There we go. Okay. Oh, this is an absolute pain to do. Okay. Okay, so we have those numbers now, and all the complex stuff is working, I think. So let's get rid of all this. Let's go back to where we were, and the weird things they were doing. Okay, so outer PVE odd equals C for C in outer odd if C dot real minus 65 times C dot image minus 65 is greater than 0. What? Or C for C in outer even if C dot real minus 65 times C dot image minus 65 is less than 0. I don't have a clue what any of this is. At least with the previous challenge where I had no idea what I was doing. When I looked at someone else's solution I could actually understand what was happening, but this I got no clue. So I'm kind of just copying what they're doing without understanding. I think it's just basically this again, but switching the conditions. So no, that's less than, this is greater than. Now they're creating a bunch of variables which are length, odd reachable, AE, BP, BN. That is, this one's even reachable. Then this one is the outer PVE, outer NVE. What? And then even half, odd half equals sorted. Total size divided by 2 minus negative total size divided by 2. And then key equals lambda x modules 2. What? And then the return is odd half to the power of 2 times AO plus even half times odd half times BN plus BP plus even half. I don't know how anyone can. I don't have a clue what's going on. Like, what any of this is doing. Like, what? How are you meant to know that you should do any of this? I don't understand at all. Okay, I guess, let's just run that. What does that return? Oh, I did a single pipe, should be OR. Wait, no, that is meant to be single pipe. Oh, I forgot this. Okay, now rerun. Total size. Ah, that is this. Sorted. I got no idea, but sure. Okay, I've got this massive number. Submit. Answer too low. I got no idea what's going on this question. Like, okay. I guess I need to double check that I have done everything absolutely exact same. C for C. Okay, I accidentally had these here. Does that change anything? No. Okay, one thing I missed. This should have the starting in it. So that could be one of the problems. Nope, it wasn't. Okay, there's also one other thing I noticed which is missing, which is also plus. There's also another one in this. So let's just do new equals directions plus 0 like that. Maybe I can do that here. Let's see. Is that the only place where that happens? Yes, it's only this one place. So maybe that changes something. Okay, maybe I need to actually do new does equals direction plus, or maybe it is just 0, like what these are ones like. Could this be the number now? Okay, well, I don't have a clue how this challenge gets solved, because this math going on right here makes no sense to me. And to be honest, I don't know anything about real and imaginary numbers, so that is meaningless to me. Well, if any of you watching this understand this, please let me know, because I'd really like to know and understand what this is, because it's kind of meaningless to me. Looking at it's just words on screen. So, if you somehow found any enjoyment in this video, make sure to like and subscribe so you can watch me basically just copy other people for the rest of these Advent of Code challenges, because I don't think they're going to be getting any easier. But hopefully for the remaining ones I actually learn and understand what is going on.